In the last section, we were working on solving equations. So this first line here, line number 1, is an equation that a team was solving. One of their team members got called to the office, and their team member ended up with this equation here on line 4. So we're basically going to look at how they got from step 1 to step 4, and then put this on a graph for you. So the first thing that we learned about was creating two separate equations. So we set the left side equal to y, which is here, and the right side equal to y, which is here. And when we graph those, our solutions are at the intersection point. So we have -3 and 2. And again, we only care about the x values because this equation has the x variable in it. Now, if I take these graphs away and we graph the team member who left, if we graph their equation, we can see that, again, the x-intercepts, or the x that we care about, is here at -3 and 2. But how did this person get from step 1 to step 4? Let's take a So I want to take a quick look at how our team member got from here to here, because you are going to have to use this in the next problem. So basically what this person did is they started to simplify, okay? And I always like to subtract my smaller x squared from my bigger. So I'm going to subtract x squared on both sides from here. That will cancel this out, okay? So that means I need to move my 4x over as well, which means I'm going to subtract 4x. And I'm just lining them up with the correct term that I'll subtract them from. So that cancels out. And lastly, I'm going to subtract 3. So that cancels out. Now the key is we're not just left over here with nothing. You do have to put a 0 as our placeholder. So put a 0 there. Then if I do 2x squared minus 1x squared, I end up with x squared. 5 minus 4 gives me a positive 1x. -3 minus 3 gives me a -6. So we can see kind of where we're getting here. Now I know that if I'm going to put this on a coordinate grid or a graph, I have to have it equal y. So they just replaced their 0 here with y. So we had x squared plus x minus 6. And then because of our commutative property, we can just flip these sides, and that's how the person got here. So basically all they did was simplify by combining like terms to one side. So now at this step, if we wanted to graph it, we could graph it, and then we would see that our x-intercepts of this graph are the solutions, or we could factor this. So I'm going to show you how to do that here. So I'd have x squared minus 6, and I need values that would multiply to 6 but add to 1. So that's going to be 3x and 2x, and the 2 needs to be negative because -2 plus 3 would give me that positive 1. So I end up with x plus 3, x minus 2, and when I set each of these equal to 0, I get those two solutions that we found previously on the graph, or our x-intercepts.